Thanks for coming, everyone. I'm Alex Viana. I'm the VP of Data at HealthJoy. We're a Chicago-based health tech company. In my role there, I have the pleasure of leading our data team. And the team is composed of myself and 4 other analytics engineers. We're lucky that we've been using dbt since our team was formed about 2 years ago. And we've always been working in kind of that analytics engineering framework. Our title has always been analysts. And so this week, next week, depending on when I hit send on some emails, we're going to change our titles to analytics engineer to kind of match the work we've always been doing. We're very excited about that. You can read about that on our team's Medium blog, which will also be unveiling later this week whenever I have time to hit send. And then lastly, we are hiring. We're looking to grow our team. We'll be adding a couple more analytics engineers next year, but in the very near future, we're going to be looking for anyone who has expertise in the healthcare data system, especially claims and healthcare outcomes. If you have that or are interested, please reach out to myself or anyone on my team, or just keep an eye on our pages. My talk is on prototyping for data teams. And so this is a preview of my Coalesce talk. I've been working on this for most of the year, shopping it around at different kind of meetups, writing about it on my personal blog. So I would really love any feedback anyone has before I kind of present this at Coalesce. I'd love to hear from folks what's resonating, what's not. So the current working hypothesis that I've been kicking around is that data is really a lot like user experience. I've seen a lot of very smart people get in meetings with me, with my team, and talking about stuff, not just here at other companies, and just kind of not fully grasp what's being implied by some of the decisions we're making. And I really feel like it's kind of like UX in that way. Like you can draw the mock-ups and talk about where the buttons and the experience should be, but until you really get your hands on it, it's really hard to kind of give real feedback and interaction and kind of innovate and talk about what you're working on. My goal here is to kind of get us to thinking about how to accelerate that process, to get something in people's hands that they can start to have a real conversation about requirements and stuff. And that, I think, is accomplished through, spoiler alert, if you've worked in data, you've probably seen projects fail. And the thing that I think is interesting about what I've seen working in the data space is that I don't see projects fail for these very highly technical reasons, like some misunderstanding of some complex statistical analysis, some corner case in a neural net, something related to an obscure plugin. Those are certainly possible. But much more often I see things when you're looking back in a retrospective, they seem obvious or maybe even embarrassing that you didn't think about them before. Things like no one ever actually looked at the data before and they didn't realize that it's too messy and malformed to actually solve the problem. Your data actually just solves like hurdle 1 of 5 hurdles that no one actually explained to you are subsequent asks of this. There was just a total misunderstanding about what the requirements were. People were using words that didn't mean the same thing. One of my personal favorites is when you can't actually connect 2 data sets. There's not actually an overlapping unique key that you can disambiguate on. In healthcare, we see this all the time. Or my actual personal favorite is no one actually knows how to answer the question. They want you to find something that is better or an improvement or important or significant, but no one can actually define what that means for you, right? These are things that when I lay them out, like again and again, I find myself in projects that run into these. And these are projects that are being worked on by very smart people. And I'm just gonna give a little bit more stress to this point. As we move from being folks that are kind of in the traditional analytics space, not to knock that at all, but into the analytics engineering space, which is more empowered, more high impact, more kind of upstream and involved in designing the project, building the wrong thing is really expensive. And it's getting more and more expensive. It's not just, oops, this spreadsheet is wrong. It's you have purchased the wrong connector. You have spent a week building the wrong set of pipelines and QAing them and testing them and documenting them. Like screwing up is becoming a bigger deal. And that's part and parcel of the kind of work we've actually asked to take on. So I think this behooves us to think a little bit more carefully about what we can do to avoid this stuff. I think you can catch these problems with prototyping. And I think this is important because you can do it before you build anything. So this is a weird talk because I'm going to ask you to, in a DBT meetup, make more spreadsheets. This is kind of the antithesis of everything we, first hit pip install dbt to do. I think it's really important. I think spreadsheets and things like that are kind of this way of getting this quick feedback process with something tactile that you and your stakeholders can gather around and make changes like immediately before you start going into all the time and investments to build a mature pipeline, which is your end product. And I don't think this is like snake oil or magic dust. I think this is kind of a fundamental exploring of the solution space that seems silly until you get in the habit of doing it. And then to me, it reminds me of version control or unit tests where if you're not doing it, suddenly you start feeling freaked out. You have this panic of like, I don't know if this is even the right thing as you're building your models. So returning to these cases I showed, you can think about this: is your data too messy to actually solve the problem? Had someone actually just pulled a spreadsheet of the data, you probably would have caught a lot of data quality issues that might end up being a bottleneck. If someone had actually tried to manually go through a processing pipeline, just again with a spreadsheet or even whatever is your representation here, you might have realized that you can't go end to end on this. If you show someone a spreadsheet output that is supposed to represent your dashboard before you build it, you're going to, oh my God, those are giant eyes, Rosie. Did not expect those. It's going to show that like, wait, that's not, we can't use that plot, or all these things are going to start falling into your lap. If someone says, hey, find the data in here that's relevant, pull up a spreadsheet of the data and be like, help me find what's relevant. And instead of being maybe more adversarial, can you define what's relevant? This is the part that's hardest. And when you go through this process, it feels like a giant waste of time because you're not answering the question, but you're figuring out what the answer looks like. And that is really important context. I think it's just fundamentally difficult to articulate as stakeholders or even as practitioners of data. Like you just need something that is tactile. This kind of, our descriptive language doesn't give us enough triggers and clues to kind of dig deeper and spot these things that aren't kind of surface level. Let's look at some examples here of what I'm trying to do. This is the easiest version of this I can think of. And again, this is going to feel really stupid, but to just make up an answer and just chuck it out there and pretend that that's the real answer and see how your stakeholders react. For example, I was in a call earlier this week where someone was asking the average number of people on our concierge staff at HealthJoy that are ever on our chat server. Right away, people started talking about, does this need to be real time? Can this be batched? Which cloud service should be using for this? What's the delivery deadlines? What are the data schemas? Should data be defining the data schema? Should engineering be defining the data schemas? And I was falling into the same trap, and it was great. It felt like real work. We were defining all of the requirements. But there was a voice in the back of my head that was like, we have no idea what we're actually trying to build here. And so I just told the main stakeholder, I was like, okay, you want an average. Let's pretend I calculate the average. It's 3. There are 3 people online. What are you going to do? And right away, they're like, oh, well, I can't use that. I need a daily average. And I was like, okay, let's say it's 3 every day. And there's a little bit of wiggle, but it's generally always 3. What are you going to do with that? And they're like, oh, well, and then all of a sudden they started describing, well, we actually care about missed chats. We need to be able to take the chats that were missed and we need to be able to correlate them with the number of the users that were online at that given time. And then I was following up with like, okay, let's say I can give you that. If you miss any chats, don't you just need to hire more people and staff more, right? And we just kind of kept ping-ponging back and forth with me offering hypothetical questions and hypothetical answers and them responding to it. It felt very weird, like even for me, like having done this a while, that people are going to get mad. They would think I was wasting their time. But again, I just kept getting all of this feedback and like a very clear vision of what my users wanted to do that I never would have gotten had I gone through the usual roadmap of what's the delivery deadlines, what's the data schema, who's in charge of what. The next one here is a little bit more complicated. So instead of just making up the answer, now you have to just fake the data. This came up in a lot of the work we've been doing in our company around reporting our annual recurring revenue and our contracted annual recurring revenue. It turns out that these are actually really notoriously difficult things to get right. One, they're very high visibility. They tend to go to the board and to the executive team. But also, this isn't like your best accounting practices. There are different ways for every company to decide what it considers to be recurring revenue, what it considers to be contracted revenue. When you have upsells, downsells, contractions, churn, all of that stuff is subject to how you want to define and run your business. And so this was extremely difficult to figure things out in terms of getting everyone, we'd have all these meetings and we'd say, this is the definition, and people would say, fine. And then we build a pipeline and we'd show them and they'd say, this is not at all what we want. We can't use this. And so what we started doing was basically just generating fake reports, just taking a spreadsheet or maybe pulling one company's data and saying, okay, what if we showed you this? Could you use this? Like, here's a specific corner case. We would represent it this way. Could you run the business by finding those corner cases in that way? And it felt, again, not like the kind of analytics engineering stuff we wanted to see, but it helped a lot. We were able to get very much more specific feedback about whether they were able to find the corner cases, respond to the corner cases. It's still a work in progress, but I know that we saved a lot of time, and the analytics engineer who worked on this thanked me. He was like, I have so much a better idea of what I'm supposed to build having done this already in a spreadsheet and known that executive stakeholders have already seen it. So another example here is to just run your whole thing by hand. So this is going back to my favorite find the value thing that data teams sometimes get asked to do. So our product team wanted to roll out a new product feature that was driven around increasing healthcare savings. They had a really good thesis, and I actually really agreed with it. But the problem was no one could tell us how exactly we were going to save the money. And part of the problem was it was around a data integration, right? That didn't exist yet. We weren't going to have the data for a year, and there was a good chance that we were going to be able to save money. But at the end of the day, the data team was going to have to find the way to save money, which is what keeps me awake at night. So rather than fretting about this, we found some representative data and basically faked the product impact. Let's just say it was dental information. And we started saying like, okay, well, I don't know, if you can save 15% on 30% of your dental examinations, and the average dental examination costs $50, and the number of examinations we see in a different database we have access to looks like this is kind of how well our product would work. And we could be totally wrong on every single one of those assumptions, but all of a sudden, like our stakeholders were able to like respond to this, and they would say, no, this should be higher, that should be lower. Or all of a sudden they were able to say, we have a threshold for how much money we need to make off of this, or maybe we should start reading some white papers. Like all of a sudden we had these actionable levers we could turn, even though we were a year away from getting real data and having to respond and build out a real system. So again, thought it was particularly valuable. That's kind of the fire hose version of this talk. When I give it at Coalesce, I want to spend a little bit more time diving into these examples and talking about how this connects to some ways I think I see prototyping used in product development and engineering development. But again, I would love any feedback on how folks think this is resonating or not resonating or whatever.
I'll surface one that I think is great. Do you have any preferred tools for generating the fake data sets or sourcing the data?
So what I've had the most success with is just pulling representative data from our company's databases. If you want to talk about the utilization of some feature, right, just pull it for one company. Maybe a company that you think is a particularly good example of your star customer, or sample. If I'm looking for corner cases, I'll try to find a company or a type of user that is a corner case and pull those folks. We haven't had to do too much just wholesale, like make up the entire thing. And when we do, it tends to be kind of an area where people are okay with us just saying like, okay, we have a hypothetical company, they have $1,000 in monthly recurring revenue. If we were to do this increase, blah, blah, blah. We haven't gotten to the level of like real data science statistical like faking of the data, but I think that would be an excellent approach if your team is already there. We're still at the fundamentals.
Awesome. Thank you. I think you're free to pick any of these other ones that look interesting.
Okay, cool. So the stakeholders have responded pretty well to this approach. There are some soft skills here, but generally the way I feel it's been perceived is taking an interest in their problem and trying to understand it holistically. I think there's a sense of like a relief, filled me exactly, that is what I need, or the subsequent conversation, again, I think makes them feel better. So like the best results, avoiding these landmines of like, oh my God, I would have spent a week building the wrong thing, which is always kind of a hard thing to quantify, but you definitely know it when you feel the blow past you and not actually hit you. The worst reaction I've gotten with this is this doesn't make other problems go away. And you can feel like I kind of could have done so much worse, but like if you still have miscommunications, if you still have scope creep, if you still have poorly defined problems, this isn't going to be a magic bullet that takes care of all that stuff.